You do it without thinking. Every single day, your brain divides things. You split a pizza, you share a bill, you calculate how long a drive will take. Division is so natural to your mind that it feels like breathing. So why does the entire mathematical universe collapse the moment you try to divide by zero? This is not a trick question. It is not a gap in your education. The answer is far stranger than you think. Let's start with what division actually is. When you divide 10 by 2, you are asking a question. You are asking, how many times does 2 fit into 10? The answer is 5. Simple, clean, satisfying. Now ask the same question with 0. How many times does 0 fit into 10? How many times can you take nothing away from something before it disappears? You can take 0 away from 10 forever, 1,000,000,000,000 times, an infinite number of times, and 10 never changes. It never shrinks. It never reaches 0. The question has no answer, or rather, it has too many answers. And in mathematics, those two things are exactly the same problem. The mathematician Georg Cantor spent his life staring into infinity. He discovered that infinity is not one thing. There are different sizes of infinity. Some infinities are bigger than others. When you divide by 0, you are not just getting a big number. You are not approaching infinity in any clean sense. You are tearing a hole in the number line itself. You are asking mathematics to point in every direction at once. Here is the rule your calculator knows, even if it cannot explain it. Every division problem has a partner. When you say 10 divided by 2 equals 5, you are also saying 5 times 2 equals 10. Those two facts are mirrors of each other. They are inseparable. They define each other. Now apply that same logic to 0. If 10 divided by 0 equals some number, call it x, then x times 0 must equal 10. But anything times 0 is always 0. Always, without exception. There is no number in existence, no matter how large, no matter how strange, that you can multiply by 0 and get 10. The mirror shatters. The partner cannot exist, so the division cannot exist either. This is not a limitation of human intelligence. It is not something future mathematicians will eventually solve. It is a structural impossibility baked into the foundation of arithmetic itself. But here's where it gets genuinely strange. There is a branch of mathematics called projective geometry where mathematicians do something almost unthinkable. They add a point called the point at infinity. They essentially say, let's pretend there is a place where parallel lines meet, a place beyond the edge of the number line. And in that system, you can approach dividing by 0, even if you cannot land on it cleanly. The mathematician Bernhard Riemann built an entire sphere out of this idea. He took the flat number line, wrapped it into a sphere, and placed infinity at the very top. In his model, dividing by 0 sends you flying straight to the top of that sphere. It is not undefined, it is just somewhere else entirely. So division by 0 is not impossible because mathematicians gave up. It is impossible in ordinary arithmetic and possible in extraordinary arithmetic. The rules change depending on which universe you decide to build. Your calculator says error, your teacher said undefined. But what they were both really telling you is this: you have reached the edge of one mathematical world and glimpsed the beginning of another. Now think about what that means for the numbers you trust every day: your bank balance, your GPS coordinates, the algorithm deciding what video plays next. All of it runs on arithmetic that quietly, invisibly protects itself from 0. Every division in every computer in the world has a guard built in, a silent check, a moment where the machine asks, is the bottom number 0? Because if it is, the whole system crashes. In 1997, the USS Yorktown, a United States Navy guided missile cruiser, went completely dead in the water, not from enemy fire, not from a storm. A crew member entered a 0 into a database field that should never have received a 0. The ship's entire propulsion control system divided by 0. The network crashed, the engines failed. The ship drifted for nearly 3 hours. 1-0, one invisible mathematical impossibility, one very large, very expensive, very embarrassing problem. The mathematician John von Neumann, one of the architects of modern computing, understood this danger deeply. He knew that the logic holding computers together was the same logic that made division by zero catastrophic. He designed systems to avoid it. Every programmer after him inherited that caution. But why does zero have this power? What makes it so different from every other number? Zero is not just a small number. Zero is not just the number before one. Zero is the absence of quantity. It is the mathematical representation of nothing, and nothing has a very special property. Nothing multiplied by anything is still nothing. Zero is the black hole of arithmetic. Everything that touches it gets pulled in. Everything multiplied by it vanishes, and that is exactly why you cannot divide by it. Division asks for a reverse. It asks, what do I need to multiply to get back to where I started? Zero has no reverse. There is no way back from nothing. The ancient Babylonians used a placeholder symbol for zero but did not treat it as a true number. The ancient Greeks were deeply uncomfortable with it. The philosopher Aristotle explicitly argued against the concept of zero because he believed dividing by nothing produced a logical paradox. He was right, it does. He just did not know how deep that paradox went. It was the Indian mathematician Brahmagupta in the 7th century who first tried to define the rules of zero formally. He got most of them right. He correctly stated that zero added to any number leaves it unchanged. Zero multiplied by any number gives zero. But when he reached division, he stumbled. He wrote that zero divided by zero equals zero. Mathematicians today would call that incomplete, because while zero divided by zero is a special category of its own, called an indeterminate form, it is not simply zero. It is a statement that the answer could be anything. It is not one answer. It is all answers simultaneously, and all answers simultaneously is no answer at all. This is where calculus enters the room. Isaac Newton and Gottfried Wilhelm Leibniz, two men who famously despised each other, both independently invented calculus in the 17th century. And calculus is, at its core, a way of getting as close to dividing by zero as possible without actually doing it. The concept of a limit is a mathematical whisper. It says, I will not divide by zero, but I will get infinitely close to it. I will watch what the answer approaches as the bottom number shrinks towards zero without ever touching it. And that approach, that infinitely careful creep toward the edge, turned out to unlock physics, engineering, medicine, economics, and virtually every quantitative science that followed. So division by zero is the wall that calculus was built to walk alongside. Every time a physicist calculates the path of a satellite, they are using limits. Every time an engineer designs a bridge, they are using limits. Every time a doctor models how a drug moves through your body, they are using limits. All of it is the mathematics of almost dividing by zero, the mathematics of approaching the impossible without stepping into it. And yet, even knowing all of this, computers still fail, rockets still crash, systems still error. Because somewhere in a billion lines of code, a denominator reaches zero and the entire structure collapses. The mathematical universe does not forgive carelessness. It does not offer second chances. Zero is patient. It waits. You do it without thinking. Every single day, your brain divides things. But now you know what your brain quietly avoids. Every time you split something, every time you share something, every time the answer comes out clean and satisfying, you have successfully sidestepped the one number that breaks everything. The one number that is not just small. The one number that is nothing. And nothing, it turns out, is the most powerful thing in mathematics.